we are going to discuss the scheduling algorithm that we are going to discuss afterwards, the different types of scheduling algorithms that are used for scheduling purposes, and the terminologies, the time terminologies that are used with it. Firstly, what is scheduling? If all the processes which are ready to execute and are placed in main memory, then selection of one process is known as scheduling, and after the selection that process gets the control of CPU. So this selection process is known as scheduling, and the algorithm we use to schedule the process is known as scheduling algorithm. So there are different types of scheduling algorithms that we are going to see, and we are going to discuss all the scheduling algorithms one by one. Before that, we have to get an understanding of the terminologies that are used for doing this. First one is CPU utilization. So what is CPU utilization? It means that keeping the CPU as busy as possible. That means utilizing the CPU at its max. Then coming to throughput. Throughput is nothing but the measure of the work, that is the number of processes that are completed per unit time, which helps to calculate the CPU utilization and efficiency of the CPU. That means a number of processes that are execution per unit second or per unit time. Now what is turnaround time? Turnaround time is the interval from the time of submission of a process to the time of completion. That means the duration taken by the process to complete its whole task, including the CPU time as well as the IO time. Now, what is waiting time? The sum of the periods spent waiting in the ready queue. That means amount of time a process has been waiting in the ready queue to execute its work. Now what is response time? It is nothing but the first time the process hits the CPU to get utilized or starts executing. Now what is arrival time? The time at which the process enters the ready queue. What is burst time? The amount of time required by the process to finish its work, that is the amount of time required to complete its work to go to the termination stage. Now what is completion time? The time at which the process completes its execution. These are the terminologies. Now there are some formula that we are going to use to calculate the waiting time and the other things to understand the utilization of the CPU and the efficiency. Now the first thing is the start time. It is the time where the process started executing, the finish time where the process finished its executing, and the arrival time, as already discussed, the time at which the process enters the ready queue. Now turnaround time, it is the duration taken by the process to complete. In a ready queue, that is from the ready run and up to termination state, the process is either waiting or using its burst time. That means the total time required to complete its work. So either executing a process is either executing or waiting to get processed or waiting to get executed. So turnaround time is the total duration of this. So turnaround time is equal to burst time plus waiting time. It can be also written as finish time minus arrival time. These are the two formulas, but we are going to use burst time plus waiting time because this is easy to use and easy to understand. Now coming to the waiting time. Waiting time can be written as start time minus arrival time or turnaround time minus burst time. Why turnaround time minus burst time? Waiting time is the amount of time of a process that have been waiting in the ready queue. So it is the waiting time, and the turnaround time means the total time taken. So if we total time taken minus burst time, if we give, that is the time which is being utilized by the process, that gives us the waiting time. So that is why waiting time is turnaround time minus burst time. Now response time is first response minus arrival time, that is the first time the process hits the CPU. Now there are two types of scheduling algorithms. One is non-preemptive and another one is preemptive. What do I mean by non-preemptive? It means that if a process is starts executing in the CPU, it won't leave the CPU until and unless it finishes its execution. Okay, so if a process P1 starts executing in the CPU, in non-preemptive scheduling algorithms, we won't take out or interrupt the process until and unless it is getting finished thoroughly. But in preemptive measures, if a process gets started executing, the process might get interrupted in the middle of its execution. That is known as preemption. So preemption occurs if a high priority, suppose say P1 is getting executed, but at some point of time, say at X point of time, a process P2 comes of higher priority. At that moment, what the CPU does, it sends the process P1 back to the ready queue and takes the process P2 and starts executing it. So this is known as preemptive scheduling algorithm. Now we are going to say all these things while we do the other algorithms. It will be more clear to you. So non-preemptive means if we start a process, a P1, if it starts executing its process, it won't get interrupted until and unless another process, means it finishes its execution. So even if the high priority or anything comes by, but in preemptive, it might get interrupted in the middle, so that a high priority or any other, whatever the algorithm is, according to that, it might get preempted. So these are the two types of scheduling algorithm we use. Now, what are the scheduling algorithms that we are going to discuss? The first one is first come first serve. The second one is shortest job first. By the names, you can get a clue of what is the algorithm doing. But we are going to discuss all these algorithms in different lectures so that you understand very pretty well. So this is the gist of the algorithms I am telling. We are not going to discuss in this video. From the next video, we will start from FCFS. So the first come first serve, shortest job first. That first come first serve means the first process that is going to get in the ready state, we are going to do it first. Shortest job first means the shortest job is going to get executed first. So you can get the meaning, bit of the meaning of the algorithm, what the algorithm is doing by the names only. Shortest remaining time first, round robin. Round robin is a time quantum factor which we are going to see. It won't give you the idea. Longest job first, longest remaining time first, highest response ratio rate, which is going to take a ratio of W by N, that is nothing but W plus S by S, that is waiting time by the burst time, and priority scheduling, that must be a preemptive one, as already can be understand. So priority scheduling, these are the 1 2 3 4 5 6 7 8 scheduling algorithms we are going to see. And this is it for today. The main topic was to make you go through or understand the terminologies we are going to discuss, we are going to use while doing this scheduling algorithms. So I hope you like this video, and thank you for watching my video. Please to like and subscribe our channel for more videos like this, and keep hitting the subscribe button to encourage us. Thank you.